Okay, is my screen visible? Are we good to go? Thank you for confirming. Okay, guys, so we were discussing about, we have completed discussing about the comparator object, and now today we are going to start the queue interface in Java, right? The queue interface, and let us try to understand something about the queue interface. So let me open the picture, and yes. So we have already discussed about, we have covered this part completely. We have covered list, and we have also covered about the set. Now it's our responsibility to also cover the queue interface. So this part, this session needs to be covered, right? So this is what I'm talking about, queue. Let us understand what is queue. First we will understand what is the queue interface. Then we will try to understand about Dequeue and priority queue, followed by array Dequeue. Right? So let us try to understand about the queue interface. So by looking at this diagram, just by looking at this diagram, so we can come to a conclusion. So what is that the particular conclusion that you can have? Queue interface is the child interface of collection interface, right? So this is one conclusion that we have. So before even writing that conclusion, I want to I want to tell you about when it was introduced actually, right? So it was actually introduced in JDK 1.5 version. Okay, it was actually introduced in JDK 1.5 version. So this point is very important. So please make sure that you remember this point, 1.5 version. Okay. The second point that I want to introduce is, so by looking at this diagram, can we conclude that it is the child interface of the collection? I mean, it is a child interface of the collection interface, right? So we have one more point in our hand. So queue interface is the child interface of collection interface. The second conclusion that we have, right? And the third point, this point is very, very important to understand about this queue data structure. So queue follows an algorithm. Queue follows an algorithm called FIFO. So FIFO is an acronym. FIFO is an acronym of what? First in, I think you might have heard about this algorithm. First in, first out. A very famous algorithm. So we will understand why one has to go for this FIFO algorithm. So when I say FIFO algorithm, so just try to what is the thing that you get when you hear the word queue? We know what is queue. Okay? Not in the Java context. So in the real-time context, we know what is queue. Queue is like standing in a queue. You can call it as, for example, right? So let me introduce a small picture here. Okay, so when you are visiting a theater or when you are visiting a railway station, when you want to do some booking, what you usually do, right? You usually, you just stand in a queue, isn't it? Right? So if you want to book a railway ticket, so you go to the ticket counter and you stand in the queue, right? So if you imagine this, okay, this is a real-time analogy, right? And if you are going to the cinema theater, if you're visiting the cinema theater, right, everyone will be standing in a line. So you call this as a queue. Okay. For example, the first person who is coming in will be the first person who is going to go out. Right? That is why we call it as what? First in, first out. Are you getting it? The first person who is reaching the ticket counter, for example, if it is a big movie like in Andhra, it's Pawan Kalyan, something, if there is a Pawan Kalyan movie, the first person who is standing in the queue, waiting in the queue for the long time, he is going to be coming out first. Likewise, the second person who is going to come in, right? So the priority will be given for the person who is coming first, and he will be given the first ticket and he will be going out first, right? And the second person comes, right, and he will be going out, and the third person comes in and he will be going out, right, and the fourth person comes in and he will be going out. After taking the ticket, he will be going out. So this analogy is called as what analogy? We can call it as what? The FIFO analogy, FIFO algorithm. FIFO means what? First in, first out. Right? First in, not only in the movie theater. For example, if you want to book tickets for your book tickets in the railway station, you stand in the queue. Right? If you want to take medical attention, if you visit an hospital, you stand in the queue. So there is a concept of queue everywhere. If you want to take darshan in a temple, you stand in a queue, right? And what does it say is the people who is standing waiting there for the long time, and the person who has come first, he will be given the first priority. That's why it is called as what? First in, first out. We call it as what? First in, first out. So this is a real-time analogy. So we will apply that by using the programming language. So you must understand what is first in, first out. Okay? Right? And the fourth thing is, when you add an element in a queue, you call it as Enqueue. Like the process of adding an element in a queue is called as what? Enqueue. The process of removing an element, from a queue is called as what? Dequeue. So we call it was Dequeue. Right? The process of removing an element. When you remove an element from a queue, okay, that concept is called as what? Dequeue. Right? And the sixth point, let me take a small Java program to understand something about this queue better. Right? So I am taking a class, and the name of the class is driver class, and I want to introduce something about queue. Right? So let me import a queue interface. Queue is an interface. So it is in java.util package. So I need to import this. No, not this one. 1 minute. Right. It's in java.util package, and I want to add some numbers, guys. I want to add some numbers. Integers in the form of integer. Okay, I want to add some numbers equal to new. So since this is an interface, you cannot create an object for the interface. So we need to use the implementation classes. What are the classes that implements queue? You go and look into the diagram. So we have a class called priority queue that is implementing this queue. So I'm going to use the priority queue class for the implementation to create an object. Right? So priority queue. Right? I want to add some numbers. So let me add some numbers really quick. So numbers dot add, first number can be something like 20. Okay, so I want to add something around okay, let me quickly add some numbers. So I want to add 20. First number is 20. Second number can be 10, and the third number I want to be 12, and the fourth number I want to be 1. Fifth number I want to be 5. Sixth number I want to be 21. Seventh number I want to be 30. Okay, numbers are added randomly, right? And let me print these numbers. Right? So if I print, let me do this numbers. So if I try to print these numbers, you will get something in the console. By looking at that value, we will be able to understand. See, the order is different, so the numbers are added in a different order. 20 followed by 10, 12, 1, 5, 21, 30. Right? And the output is in a different order. Can we say that output is in the form of sorted order? No, output is not in the form of sorted order. right? But it is maintaining some order. We need to find out why the output is like this. So either it should be sorted, that is fine. It is not sorted because there is a violation. So till here it is sorted, and after this, you are getting a different number here. So what does it mean? Output is not in the form of sorted order, right? So I have a conclusion. The conclusion is like it does not follow sorting order. So why it does not follow sorting order? What order it is going to follow? That I will explain you. Right? By looking at the output, I can come to one conclusion. What is that one conclusion? It is not going to follow sorting order. Okay, is it following insertion order? Okay, if sorting order is not followed, that is okay. We need to find whether it is following insertion order. Is it maintaining insertion order? Right? We have inserted the elements in this order: 20 followed by 10 followed by 12, and we have 1 followed by 5 we have, and 21 we have, and followed by 30 we have. This is the insertion order. Is this insertion order preserved? No, it is not, because the output is coming in different order. So I have another conclusion. What is another conclusion? It is also not following the insertion order, right? It does not follow insertion order. Second conclusion. Okay. And let me add a duplicate so that I want to test whether this is accepting duplicate. Intentionally, I am trying to add the repeated value 30. I am repeating it once again, right? When I do this, what is the actual order? So this is our actual order. Okay, so in our numbers, in our objects, we have a duplicate. I am intentionally placing a duplicate to check whether it is accepting duplicates or not, right? So duplicate is also accepted. It is allowing duplicates. So I have a conclusion. What conclusion I have? It allows duplicates. It allows duplicates, right? And I also want to check whether it is allowing a null value or not. I also wanted to check what? I also wanted to check whether this priority or whether this queue is accepting a null value or not. So intentionally I am adding a null just to check whether this null is accepted or not, right? Making sense? So this is the null, and this is our order null. So this is our insertion order, and we are going to find whether the value null is accepted by the queue interface or not. So it is not accepted. So I have another conclusion. What is that another conclusion? So we are getting a null pointer exception when I try to add a null value, isn't it? So I can say that it will not allow null values, and when it is violate, and when you try to add a null value, you will get what exception? java.lang.NullPointerException. Right? Now I also want to check whether it is accepting the heterogeneous element or not. So all these elements, if you see that, if you focus here, the elements that I have added, okay, remove this, the null value is not accepted. So we have done the experiment, so we do not want to think about null anymore. So I want to check whether it is accepting the heterogeneous element. So in order to check that, I need to remove the generic type, right? So if you look at this, if you look at the way the objects are added, all the objects are in the form of numbers. Now I want to do an experiment. What kind of experiments I want to do now? I want to add a string value, right? Till the line number 23, we have added numbers. Now I am doing an experiment. I want to check whether it is accepting a string value like Java, right? So if I run this code, we are getting an exception. So by this exception, I can come to a conclusion that heterogeneous elements are not allowed in the queue interface, right? Please be informed that heterogeneous elements are not allowed in the queue interface. And when you add heterogeneous element, you will get an exception. What exception you are going to get? Right? So I am just doing an experiment, nothing else. I am just I have taken a program. So we are doing an experiment together to understand these constraints. As simple as that. Right? I will also tell you why it is not following sorted order, why it is not following insertion order, why it allows duplicates. That explanation I am going to give you. So these are the points that we have made as per our observation. This is our observation. Right? Our observation is valid because we have a proof that all these points are valid. Right? Now I want to introduce something. Now I want to I want to introduce you something about this priority queue. Okay? So the order is this, and why we are getting a different order here. Right? So what is happening behind the scenes? Okay? Let me remove this for the better understanding. Let me remove the duplicate also. Right? Let me remove this also. Let me remove this. Okay. So if I run this code and let me take this as the generic type integer. This way. Okay, we are getting output in a different order. So let us understand about something about the priority queue. Internal working of priority queue. Right? So just now we have seen that the importance of queue, the first in first out algorithm. So when you wherever you go, even especially in India, everywhere there is a queue because of the population, and you need to stand in the queue to get your requirements fulfilled. Anyway, everywhere, right? But priority queue says, so priority queue will work in a different way. So priority queue, when I introduce you about the priority queue, it is also going to follow an algorithm, what first in first out algorithm, but this algorithm is modified in such a way that it is going to give the priority. Please focus here. It is going to give you the priority, a kind of priority. The same example I want to explain you in a different way. Algorithm is first in first out, right? FIFO is an acronym of first in first out. The same example, it is not a booking counter this time. It is an hospital. Okay, this time this is an hospital, and people are visiting hospital, and they are standing in the queue to get the appointment, or to to get to see to the doctor. So they want to stand in the queue. Some hospitals they get the tokens. Right? So what happens? Patients are coming in the line, right? Sometimes there will be severity between each patients. Severity. So when I talk about severity, I am talking about priority. What does it mean? The first person is just sick. Okay. The second person is what? He is getting fainted. Second patient, I mean, right? The third patient is BP, like is high, right? And the fourth patient, he has a kind of different ailments, I can say that, and he is something around 38 years old. Okay, and they are standing in the queue. They are standing in the queue, and they are what they want. They are visiting the hospital, and everyone are standing in the queue. Right? By looking at these four patients, like we can come to a conclusion. What kind of conclusion that we can give? Right? Even though they are, they are supposed to stand in a queue to get an appointment, but depending upon the severity, right? This 8 years old patients, he cannot stand in the queue for the long time. Yes or no? He cannot stand in the queue for the long time. And the sick patient, right? He can what? Even though he is standing in the queue, even though he's standing in the queue in the first, he's waiting in the queue for the long time, right? He can deprioritize. Again, you can decrease his priority. right? So by looking at these 4 patients, like if you want to give priority, even though they are standing in the queue, I can come to a conclusion. What kind of conclusion I can come? Okay, so for example, the patients with the, so this patient is a critical condition patient, very critical. So he is getting fainted, means he's falling down in the floor, right? So this patient needs to be treated first. So he will be given priority and he will be treated first. Priority number 1, right? Second patient, this is second priority patient. BP patients are very severe, okay, they are very critical, they should be treated, they should get immediate treatment, right? So he is a second prioritized patient based upon the order, right? And 8 years old patient, and when you do an observation between these 2 patients, 8 years old patient, he cannot stand in the queue for the long time, so he's less critical, but still the age is 8 years old, he should be treated thirdly, and he should be treated last. You can wait for a long time, right? So according to our observation, even though the sick person is standing in the queue for the long time, he is less critical. His condition is less critical, right? Based upon this condition, and even though even though regardless of at what time he arrived, you are not going to send him first, treat him first. Instead, what you're going to do, you're going to consider the critical patient. You are giving priority number 1, priority number 2, priority number 3, priority number 4, priority number 2, priority number 3, and priority number 4. Okay, this concept is called the same analogy is being followed by what? Priority. Interesting, isn't it? Priority. But the question is, what priority does the number has? That is the question. Here you are dealing with the patients. Of course, it is making more sense when you talk about the priority. But I have just added the numbers here. I have just added the numbers in this order. Okay, numbers are added in a random order. This is the actual order of our numbers that has been added in the priority queue. Right? What priority does it numbers has to do with? What priority does it numbers are? This is the order that the numbers are added, but this is the priority. The numbers are given. Let me run this once again. Okay. When you display this in the output, so this is the priority, the numbers are given. Center. Okay, when you take this in the queue, for example, just imagine that this is a queue. Just try to understand that. This is the queue. Okay, this is the entry. This is the entry. Okay, and we call this as what? Enqueue. The process of adding element into a queue is called as what? Enqueue. And the process of removing an element from a queue is called as what? Dequeue. What does it mean? Dequeue. Adding an element and removing an element. Okay, remember this, get acquainted with this word so that Dequeue. Right? So what is the order of element that we have added? So we have added elements, right? So first 20 is added, second 10 is added inside the queue, Enqueue, we are enqueuing it, right? Third 12 is added, right? And the fourth is 30 is added, and fifth is 1 is added, right? Sixth is 5 is added, and seventh is 21 is added. According to our first in first out algorithm, according to the FIFO algorithm, okay, the elements that are added in the order, there should be the same elements that should be dequeued, right? If you are adding some elements in the process of enqueuing, okay, the element should be removed in the same order by using the FIFO principle. Okay, but when you look at the output is something like number 1 is given first priority. Okay, it is coming out first, followed by number 10 is coming out first. It is somewhere here. Okay, how the priority is getting decided? I hope you are able to get the question. The third is number 5 is getting out. fourth is number 30 is getting out. How this priority is getting is decided. So in the previous example, we are able to decide the priority based upon the patient conditions. But all these are numbers. How the priority is getting decided? How this order is getting maintained? What kind of algorithm is happening behind us? Is that we will understand. Okay, for this fifth number is 20. 20 is getting dequeued in the fifth time, and we have 12 is getting dequeued. Then 21 is getting dequeued. It is not following FIFO. Something internally, something it is following. Okay, that something is called as what? It is following an algorithm called the EP5 algorithm. EP5, and we call it as what? It is following min priority. EP5 algorithm and mean priority. Don't worry about this word. We are going to see these things in action. Okay, we want to understand why the order is like this. Okay, I'm going to take the same examples, and I will I will help you with how we are getting this order for the periodic. Right? Shall we go? Right? What is happening behind the scenes is, before even understanding this, I want to understand something about the complete binary tree. What is it? Complete binary tree. Okay, I will give you the small heads up about this complete binary tree. So when you are saying a tree is complete binary tree, what does it really means? All the nodes are added from the left to right direction. For example, if you are adding a node, good, one node is there. If you want to add the second node, this second node should start from the left, and if you want to add the third node should be here, and if you want to add the fourth node, it should start from left direction and it should head in the right direction. So each and every node will have two children. Okay. This tree is called as what? The balanced binary tree. We can call this as what? Balanced binary tree, because apart from the root node, when I say root node, the starting node is called as root node, guys. Don't get confusion. This is called as root node. From the root node, the branches are getting created. Maximum of 2 branches will be created. Right? If every node has complete 2 branches, right, you call this as what? A complete, a balanced binary tree. But what is the complete binary tree? Okay. When I say the complete binary tree, okay, you can start adding the nodes from the left to right direction. Okay. All the nodes should be filled from left to right direction. Then you can call it as what? Complete binary tree. Okay, so this is a complete binary tree, and let me introduce some more examples. Okay. Okay, so if I ask you what kind of tree is it, I would say that this is also a complete binary tree. Why this is also a complete binary tree? Because you are adding some nodes from the left to right direction. Even though these nodes are not filled, no issues. These nodes are blank, nothing is there. But all the nodes must be filled from the left to right direction. That is the takeaway, right? For example, if I have 5 nodes, let me do like this. Okay. First node I am taking it as a root node. Second node I am taking it here. Third node I am taking it here. Right? If I ask you what kind of binary tree is it, you can say it is a complete binary tree, because all the all the nodes are filled from the left to right direction. And again, if I add this node, here, I can still call it as a complete binary tree, because this node has been added from the left direction. But if I start adding this node, over here. Okay, this is not a complete binary tree. Why this is not a complete binary tree? Okay, there are no nodes here. Okay, no nodes are filled. If you see here, no node is filled, no node is filled, no node is filled, you are filling a node here. So this is not a complete binary tree. If I want to make this as a complete binary tree, then what I am supposed to do, this node has to be filled from the left direction, from left to right. You see, from left to right, if it is getting filled from left to right, no matter what, if the right nodes are empty, but still this is a complete binary tree. So these right nodes are obviously empty. But if you look at the adjustment, okay, it is getting filled from left direction to the right direction. This is complete. So first root node is there, followed by 2 branches, complete, and you are adding another node from the left direction. Even though you don't have any nodes here, still it is called as a complete binary tree, right? And again, if you are adding a node here, still it is complete. And again, if you are adding node here, this is not complete because it is not getting adjusted from the left to right direction. You are missing one thing. Something is missing here. It is not complete. If I want to make this complete, I want to ensure that the node should be here. Now this is complete, even though there is some kind of a missing node. Okay, let me take few more examples for a better understanding. New. Okay. See, so this is the case 1. So we have case 1. Case 1. So case 1 is complete. Why it is complete? Root node is filled and it has 2 children, and all the nodes, each and every node has maximum 2 children. So it is complete binary tree. And if I ask you the question whether this is a complete binary tree or not, what should be your answer? Case 2, right? The case 2 says, okay, you have the root node and it has 2 branches and the nodes are getting filled from left to right. Okay, even though there is no node here, it is balanced from left to right. It is also valid. Okay, so this is the valid one. This is, you can call this as the complete binary tree. And look at this. To focus here, root node is there, followed by 2 branches, and from left to right, there are empty nodes. From the left to right direction, there are empty nodes. So this is not a complete binary tree. You cannot call this as what? The complete binary tree. This is not a complete binary tree. Case 3 fails. Case 3 is failing. Okay, and the fourth case, a root node followed by 2 branches. There is a gap here. Followed by 2 branches, and you are filling from left to right, but there is a space here. From left to right, you are not supposed to see any space. You can have spaces, consecutive spaces without any nodes, but in between you cannot have any spaces. If you have a node here from left direction, right, there is an empty space here, and again you are adding some nodes, you are seeing some nodes after this. It is not accepted. This is not a balanced tree, right? So case 4. Case 4 is also failed. Now case 5, look at the case 5. Case 5, is it complete binary tree or not? Right, root node is there, left to right, and left, right, and there are empty nodes. No, you don't need to worry. Right, these are empty, no need to worry. Consecutive empties from the left direction. If you have any nodes, it should be from the left, right, and you will have to fill the nodes from the left direction to right direction, and you cannot have any empty spaces. So this is also called as what? Complete binary tree. Also valid. So why we are discussing about this complete binary tree, I will tell you. This is invalid. This is invalid. So we have 5 cases. Out of these 5 cases, 3 cases are following the rules of what? The complete binary tree. Right? Case number 1, case number 2, and case number 5. Right? Now see, so I will explain you about the max minimum priority heap in priority. Understand this. So what are the values that we have added in the the priority queue object? What are the values? So these are the set of values that we have added. Now what is happening? What is actually happening behind the scenes? We will understand that. Before even understanding that, just try to understand this kind of algorithm. So when I have a numbers like, let me take another binary tree file, import to canvas from a file. Not this one. 1 minute, guys. Okay, no worries. See, let me take a binary tree here. A simple binary tree I want to take. Okay, I am adding some numbers. Okay, so if I have a numbers like this, for example, so what is our actual values? 20, 10, 12, 31, 5, 21. Okay, focus here, guys. These are the numbers that I want to add. So we have added these numbers. 20 is the first number, isn't it? Okay, so 20 is the first number, right? So this 20 will be placed, the first number 20 will be placed inside the root node, first node, root node. Good, so far good. Okay, as soon as this number is placed, it will try to find the second number. Second number is what? Second number is 10, right? Second number is 10. Okay, what will happen is, so it will try to occupy the position from the left to right, from the left direction to right. So it will try to position itself in this node. Okay, after placing itself in this node, what it is going to do actually here is, it will compare its number with its parent's object. For example, this is a binary tree. Okay, this is the parent, this is the child. This child is going to compare itself with the parent. Okay, after the comparison, if it finds itself as a smallest value, as a minimum value between these two comparison, if it finds itself as a minimum value, okay, this will be exchanged. 10 will go up, 10 will try to place itself in the parent's position, and the 20 will come down. We're talking about mean priority. You will get this better. Let me add few more elements. Okay, now we have what? We have 12. Okay, 12 has to be added here. This is empty space, right? As soon as it is added, it will try to compare itself with its parent. Okay, so 12 is greater than 10. 12 is greater than 10. So no swapping. Okay, if the 12 is lesser than the parent's value, there will be a swap. Okay, so let me add this. Let us add few more elements. We'll understand this. So I want to add 30. So 30 will be added. Okay, the order of adding is first this direction. Okay, first this will be filled from left to right, and left to right will be filled. This is how it is added, and left to right it will be filled. You don't get any confusion. Filling will be happen from left to right. Right? So now 30 will be added here. Okay, this 30 will compare itself with its parent. The value of parent is what? 20. So obviously it will try to check whether its value is lesser than its parent's value. No, it is greater. If it is greater, it will remain here. If it is lesser, then this swapping will happen. Okay, forget about this. Now you see. Now you will understand this better. Now 1 is there. 1 will position itself here. Okay, this 1 will try to get itself compared with its parent. 1 is lesser than its parent. Okay, the mean priority says if the object that is getting added in the node is lesser than its parent object, right? Swapping will occur. Okay, this will be swapped here, and this will be swapped here. 20 will come down, and 1 will go. Again, what will happen? Again, this will check whether if it is lesser than its parent. Okay, 1 is again lesser than its parent. Okay, so this will be swapped here. This will be coming down here. Now it will be positioned itself here. Okay, let us see. Well, 5. Now 5 has to occupy this position. This 5 will obviously get compared with this parent 12. Of course, 5 is smaller. When 5 is smaller, if it is smaller, definitely there should be a swapping. 5 will come here, 12 will come here. Right? Again, this 5 will get compared with its parent. So, of course, 5 is greater than its parent, so no swapping. Last number 21. Okay? 21 obviously will get added here. Right? And this 21 is going to get compared itself with its parent. Right? 21 is greater than its parent, so no swapping. So this is how the elements are adjusted and arranged in a complete binary tree. So all the elements are arranged in this fashion, in this order. Okay, how does these elements will get retrieved from the binary tree? That is the question. Okay, again the retrieval will happen from the left to right direction. Left to right direction. Left to right direction. Right. So first root node will be retrieved. The first value of the first thing is 1. So no doubt. So 1 will be retrieved. Again left to right direction. When I say left to right direction, this is the direction. So 10 will be retrieved. And next 5 will be retrieved. Then 30 will be retrieved, 20 will be retrieved, 12 will be retrieved, and 21 will be retrieved. Right? So this is the simple understanding about the complete binary tree and how the elements are added and how the elements are retrieved. Are you getting this? So this concept is called as what? This concept is called as the concept of min priority. So we call this as what priority? We call this concept as what priority? The min priority. We will see few more examples. You will understand this better. Right. So let us add let us add few more elements so that we will get some kind of understanding about this. Okay. Let me add. So look at, you see the output. If you focus on the output, so are we getting the same output? See the output. By looking at the output, you will get an idea now. This is the output that we got. How the output we got? So first is 1. So this is 1. Second is 10, 5. We have 10, 5. Third one is 30, 20, 12, 21. We have 30, 20, 12, 21. We are getting the right output, isn't it? What is the order that we have added? This is the order that we have added. 20, 10, 12. This is the order. We know how these elements are getting added. This is the order. Right? And after adding each element, this is getting adjusted according to the min priority. Swapping will happen if the child object is lesser than the parent object. If not, swapping will not happen. The elements will be added from the left to right direction. Right? At the same time, the elements will be removed from the left to right direction. So at the time of retrieval, okay, first element is what? 1, followed by 10, followed by 5, followed by 30, followed by 20, followed by 12, followed by 21. First example. Okay, I think you got some understanding about this example. Let me take another example for the better clarity. Focus here. People who are not getting it in the first attempt, you will have to get this. Okay, I want to add few more a different kind of example here. So I want to have the elements like let me take some elements like 10 and 1, and I want to take 3, I want to take 2, I want to take 20, I want to take 40, I want to take 30. I do not want to print now. We will try to identify what values will be printed. Okay, these are the elements that I have added. Okay, so let me go back to the screen, main screen. So file, new. Okay, so these are the elements I have added. Priority queue. This is the internal working of priority queue. right? So first number is 10. A node will be created, and obviously the value 10 will be added. Good. Second number is 1. Focus here, guys. Second number is we are adding 1, right? So a node will be created from the left to right direction, and the value 1 will be added. After once the value is added, this will get compared with its parent. Okay, this 1 is lesser than the value that we have in its parent, with its parent. So if it is lesser, swapping will happen. Okay, this 1 will occupy the parent position, and this 10 will come here. So this is the arrangement that is happening behind the scenes, guys, nothing else. This kind of arrangement is happening behind the scenes. Right, now what is the third value? Third value is we have 3. Good. Okay, it will occupy this position. A node will be created here, and value 3 will be added here. This 3 will get compared with its parent. So there will be no swapping because 3 is greater than its parent. So no swapping. Only if it is lesser, there will be swapping. Okay, now what is the fourth value? Fourth value is what? Again, what is it? I think it should be, fourth value should be 2. I have taken 3. Let me remove this. Let me take it as 2. Okay, fourth value is 2. So for the fourth value, it has to be added here. For the complete binary tree, the leaves should start from the left to right direction, right? And this is the value 2, right? Let me change. Fourth value should be, okay, the value 2, and it will compare the value with its parent value, right? This 2 will obviously get compared with its parent. It is lesser. When it is lesser, swapping will occur because in the parent node, the value is 10, which is greater, so the swapping will occur, right? And again, this value will get compared with its parent, but the value is lesser than the parent value, so no swapping. I mean, value is greater than its parent's value, so no swapping. Right, and what is the next value that we have? We have the value 20. We are adding 20. So a node will be created, and value 20 will be added in this node, and this will get compared with its parent. Right, 20 is greater than the value that you have in the parent. 20 is greater than 2, so no swapping. Right, what is the sixth element that we have? 14, isn't it? So you are adding a 14, and you are creating a node here. So these are the internal things. You are not going to create anything here. We are trying to understand how these values are adjusted behind the scenes. Okay, so just for our observation. Okay, just we need to visualize this. We are just visualizing this, nothing else. So 14 is greater than its parent's value, so no swapping. And what is the last value that we have? Last value we have is what? Okay, 13. 13 has to be added here, and this 30 will be compared with this parent. Okay, if this value is lesser than the parent value, swapping. So it is greater, so no swapping, right? So now if I print, okay, if I use I use system.out.println, but try to print numbers, we will get an order. Okay, what is the order that we have added? The numbers are added in this order. First added 10, and we have added 1, we have added 3, followed by 2, followed by 20, and followed by 14, and followed by we have 13, right? And what would be the output? This is the insertion order, and what would be the output? The output that we are going to get is, first root element will be retrieved. This is the root element. Okay, 1 will be retrieved. So in the console, 1 will be displayed, followed by the nodes from the left to right direction, okay, followed by 2, 3, right? So you have 2 in the extreme left, followed by you have 3 in the right, and again, so followed by the elements from the left to right direction in the sub branches. We have 10, 1, 2, 3, 10 we have, 20 we have 14 we have 13 we have. So we are expecting this order to be printed in the console. Are we getting the same order in the console? Shall we check it now? .out.println, so numbers, right? Let me print this. So 1, 2, 3, 10, 20, 14, 13. So now are you getting, is it matching our logic as well as the output is matching? Yes, it is matching. So now are you able to understand why the elements are printed in order, in a random order, which we haven't understood before? Now we were able to understand this, yes or no? This order, the same as the current explanation, isn't it? Okay, so when you get a question like priority queue, the internal working of priority queue says internally it uses complete binary tree with the mean priority heap algorithm, right? So the elements are adjusted in the binary tree according to the mean priority, the output elements are retrieved from the left to right direction from the root node. That's the reason why it is not following insertion order or sorting order, right? So you're able to see this is internal working of priority queue. That's the reason why we are getting an output in the random fashion. So this is explaining why the output is in the form of a different random fashion. Right? If I add another element 13 here, let me add another element 13. Okay. So what does really happen if I add 13? This 13 will be added. Okay, in this position. In this position, the 13 will be added. Okay, again this 13 will get compared with its ancestor, its parent. Okay, if the 13 is lesser than the parent's value, then the swapping will occur, but it is greater, so no swapping will occur. Right? And if I run this code, an additional 13 will be added. Don't you think so? An additional 13 is going to get added. Lastly, right? Likewise, if I add another 13, if I add another 13, so like let me add another 13. If I add another 13, okay, that 13 will be added over here, right? But still no swapping will occur. Okay, you will find the real change here. If I try to add another 13 again, that has to be added here. Now you see what will happen. Now the entire binary tree will get adjusted if it is required. 13 will get added here. Okay, this 13 is lesser than its ancestor parent. So swapping will occur, right? This will be coming here and this will be coming here. Okay. After adding two consecutive 13, if you try to retrieve this, now the order is going to change. 1, 2, 3, 1, 2, 3, followed by 10, followed by 13, followed by 14, followed by 13, followed by 13, followed by, and we have 13 again, and followed by we have 10. So this should be the output, isn't it? So we have added 4 13s. So this is how the output will be displayed in the console. Okay. So how many 13s we have added? 13, 1 13, 2 13, 3 13s we have added. Okay. Let me redo this for the 2 times. Let me run this. According to the elements that you are adding, okay, the output is getting adjusted, and this is what you are getting in the console, which is matching our values. See, both are same. Any value you can add, that will get adjusted accordingly. So this concept is called as what? Min priority. Both are matching, right? So this is how the elements will get added. So elements are added. Okay, tomorrow we will see how to remove the elements. Okay, there are some methods in the priority queue. We will see that tomorrow. Tomorrow we will complete the complete queue concept. Do you have any questions for me today? If you have, so you can text me now.